So you've probably heard the term machine learning thrown around a lot, right? It's everywhere. It's powering our world in ways we barely even notice, but it's also one of those technologies that a lot of people don't fully get. Today, we're going to pull back that curtain and explain what it is, how it actually works, and most importantly, why it matters so much.
Think about it, it's like this silent director behind your weekend binge watch. You know, when a streaming service knows exactly what movie you're going to love next? Yep, that's a machine learning algorithm sifting through millions of data points on what people watch to make a scarily accurate pick.
It's also kind of like a digital guard standing watch over your finances, 24/7. Your bank uses machine learning to spot weird patterns in transactions in real time. It's what flags that strange purchase and stops fraud before it turns into a total nightmare for you. And this is where it gets really world-changing. Machine learning is speeding up massive scientific breakthroughs. You have models like AlphaFold 3 that are now predicting how the tiny molecules of life work and fit together. That's a huge step in discovering new drugs. And this isn't science fiction. It's happening right now. So it can recommend, it can protect, it can discover. Amazing. But that brings us to the biggest question of all, the one we're here to answer. How does a machine, a chunk of code, actually learn how to do any of this stuff? Well, to get our heads around that, we first need to get our definition straight. Okay, so let's start with the big picture. Artificial intelligence, or AI. Just think of this as the entire universe of trying to make machines smart. It's the huge, overarching goal of getting a computer to simulate human-like thinking and reasoning. Now, machine learning, or ML, is a huge and super important part of that AI universe. It's not about just programming a machine with a bunch of rules. Instead, it's a way to achieve AI by letting the system learn directly from data, from experience, and get better at what it does all on its own. So remember, all machine learning is AI, but not all AI is machine learning. And if we zoom in even further, we get to deep learning. This is a really powerful technique inside the machine learning family. It uses these complex structures called neural networks, which are kind of inspired by our own brains, with tons of layers to find really subtle patterns in raw data, like recognizing your face in a photo. All right, so let's just quickly tie this all together so it really sticks. AI is the big idea, the whole field. Machine learning is a major way we try to achieve that idea. And deep learning, that's a super powerful technique inside of machine learning. And then you have data science, which is a related field that uses all these tools to find hidden patterns and figure out what might happen next. So what's the one thing that connects all of these? What's the secret sauce? It's data. And this quote just says it perfectly. You can have the fanciest, most powerful algorithm in the world. That's your engine. But if you don't have good, clean data, the fuel, that engine is going absolutely nowhere. Now, the algorithms themselves are like different tools for different jobs. For example, what you're seeing here is a classification algorithm. Its whole job is to find the best possible line to separate two different groups of things. Like, say, figuring out which companies are likely to succeed versus which might fail. It tries to draw that line with as much empty space as possible between the groups to make its predictions really confident. But then you have other algorithms that do something completely different. This is called clustering. Instead of separating groups we already know about, its job is to find natural groupings inside the data that we didn't even know were there. It looks at all the data points and clumps together the ones that are most similar. This is how a company might discover a whole new type of customer they never knew existed.
So when you have these powerful tools like classification and clustering, the real-world uses are just incredible. I mean, just look at finance. Machine learning is everywhere. It's spotting fraud, it's optimizing trading strategies, it's creating personalized financial advice, and it's building better, fair credit scores. The potential here is absolutely enormous.
Okay, so it all sounds amazing, right? A total game changer. But here's the catch. For all of its power, actually doing machine learning is not easy. As this quote from McKinsey points out, a lot of companies are pouring tons of money into these projects, but they're just not seeing the results they hoped for. So why is that?
Well, the reality is kind of shocking. According to some pretty solid estimates, the number is as high as
87%. Just let that sink in. That's the estimated percentage of these big, ambitious data science projects that never actually get used in the real world. They die on the vine. The vast majority of them just fail. So what's going wrong? Well, a lot of the time, the biggest problem comes right back to that fuel we talked about, the data. Maybe it doesn't exist, or you don't have enough, or it's just a complete mess. Then there's the talent problem. You need people who know which algorithms to use. And sometimes it's even simpler. Companies are just asking the wrong questions in the first place.
You see, the thing is, successful machine learning isn't just about some clever algorithm. It's about a really disciplined process. It all starts with gathering the right data. Then comes the really hard part that nobody talks about, pre-processing. That's cleaning, organizing, and getting that data ready. Only then can you actually use it to train your model and see how well it works.
And it's not a one-and-done kind of thing either. It's a loop. As you can see in this more detailed diagram, it's an iterative cycle. The model makes a guess, it figures out how wrong it was, and then it adjusts itself to do better next time. And it does this over and over and over again, getting a little smarter with each loop until it's good enough. But man, when this whole process comes together, the progress is just staggering. I mean, look at this timeline. This incredible acceleration isn't a coincidence. It's driven by two huge things, just an insane explosion of available data and a massive leap in computer power. Back in 1997, it was a huge deal when a computer beat the world chess champion. Fast forward to 2012, and a neural net teaches itself to spot cats in YouTube videos. Then 2017, the transformer changes everything for language, and by 2023, a model can pass the bar exam. The pace is just unbelievable. So, at the end of the day, machine learning isn't some kind of magic. It's a tough, rigorous process that combines powerful algorithms with huge amounts of data. And when you see just how far it's all come in such a short amount of time, it leaves us with one final, pretty mind-bending question. If this is what machines have learned to do in just the last decade, what on earth will they learn in the next?